According to the question, for one day, the average number of employees that are absent from the administration department is 1.2. Okay, so if X is the number of employees that are absent for n number of days, by making use of the scaling property of Poisson distribution, it is going to follow a Poisson distribution of 1.2 multiplied by n. Okay, what we want to do is to keep the probability for there to be no absentees to be a probability that is less than 0.01. Okay, and what we want to do is to calculate the smallest possible value of n, the smallest possible number of days when this can happen. Okay, we will press this left hand side here into my graphing calculator. I will generate a table to seek out that least possible n, okay, which is going to represent the smallest number of days where the probability that there were to be no absentees to be less than 0.01. If I were to press it into my calculator, the x column is going to represent n, and the y1 column is going to represent the probability that x is equal to 0. If I were to scroll down the table, when n is equal to 3, the probability is equal to 0.0273. Okay, when n is 4, the probability of this is 0.00823. Okay, it is already less than 0.01. When n is equal to 5, the probability here is 0.00248. Okay, that is why the least possible n is 4. So the smallest number of days that we are talking about, it is going to be equal to 4.